Climate change mitigation are actions to limit the magnitude and/or rate of long-term climate change. Climate change mitigation generally involves reductions in human emissions of greenhouse gases. Mitigation may also be achieved by increasing the capacity of carbon sinks, for example, through reforestation. By contrast, adaptation to global warming are actions taken to manage the eventual impacts of global warming, for example, by building dikes in response to sea level rise. Examples of mitigation include switching to low-carbon energy sources, such as renewable and nuclear energy, and expanding forests and other sinks to remove greater amounts of carbon dioxide from the atmosphere. Energy efficiency may also play a role, for example, through improving the insulation of buildings. Another approach to climate change mitigation is climate engineering. The main international treaty on climate change is the United Nations Framework Convention on Climate Change, which in 2002 adopted the objective to prevent dangerous anthropogenic interference with the climate system. In 2010, parties to the UNFCCC agreed that future global warming should be limited to below 2.0 degrees Celsius relative to the pre-industrial level. Some analyses suggest that staying within the 2 degrees Celsius guardrail would require annual global emissions of greenhouse gases to peak before the year 2020, and decline significantly thereafter, with emissions in 2050 reduced by 30 to 50% compared to 1990 levels. Recent analyses by the United Nations Environment Programme and International Energy Agency suggest that current policies are too weak to follow the pathway for staying within the 2 degrees Celsius guardrail. Other recent analyses challenge both the pathway and the 2 degrees Celsius guardrail itself. Background: greenhouse gas concentrations and stabilization. One of the issues often discussed in relation to climate change mitigation is the stabilization of greenhouse gas concentrations in the atmosphere. The United Nations Framework Convention on Climate Change has the ultimate objective of preventing dangerous anthropogenic interference of the climate system. As is stated in Article 2 of the Convention, this requires that greenhouse gas concentrations are stabilized in the atmosphere at a level where ecosystems can adapt naturally to climate change, food production is not threatened, and economic development can proceed in a sustainable fashion. There are a number of anthropogenic greenhouse gases. These include carbon dioxide, chemical formula, CO2, methane, CH4, nitrous oxide, N2O, and a group of gases referred to as halocarbons. The emissions reductions necessary to stabilize the atmospheric concentrations of these gases varies. CO2 is the most important of the anthropogenic greenhouse gases. There is a difference between stabilizing CO2 emissions and stabilizing atmospheric concentrations of CO2. Stabilizing emissions of CO2 at current levels would not lead to a stabilization in the atmospheric concentration of CO2. In fact, stabilizing emissions at current levels would result in the atmospheric concentration of CO2 continuing to rise over the 21st century and beyond. The reason for this is that human activities are adding CO2 to the atmosphere far faster than natural processes can remove it. This is analogous to a flow of water into a bathtub. So long as the tap runs water into the tub faster than water escapes through the plug hole, then the level of water in the tub will continue to rise. Stabilizing atmospheric CO2 concentrations would require anthropogenic CO2 emissions to be reduced by 80% relative to the peak emissions level. An 80% reduction in emissions would stabilize CO2 concentrations for around a century, but even greater reductions would be required beyond this. Stabilizing the atmospheric concentration of the other greenhouse gases humans emit also depends on how fast their emissions are added to the atmosphere, and how fast the GHGs are removed. Stabilization for these gases is described in the later section on non-CO2 GHGs. Projections of future greenhouse gas emissions are highly uncertain. In the absence of policies to mitigate climate change, GHG emissions could rise significantly over the 21st century. Numerous assessments have considered how atmospheric GHG concentrations could be stabilized. The lower the desired stabilization level, the sooner global GHG emissions must peak and decline. GHG concentrations are unlikely to stabilize this century without major policy changes. Energy consumption by power source, to create lasting climate change mitigation, the replacement of high carbon emission intensity power sources, such as conventional fossil fuels, oil, coal and natural gas, with low carbon power sources is required. Presently fossil fuels supply humanity with the vast majority of our energy demands, and at a growing rate. In 2012 the IEA noted that coal accounted for half the increased energy use of the prior decade, growing faster than all renewable energy sources. Both hydroelectricity and nuclear power together provide the majority of the generated low-carbon power fraction of global total power consumption. Methods and means. Assessments often suggest that GHG emissions can be reduced using a portfolio of low-carbon technologies. At the core of most proposals is the reduction of greenhouse gas emissions through reducing energy waste and switching to low-carbon power sources of energy. As the cost of reducing GHG emissions in the electricity sector appears to be lower than in other sectors, such as in the transportation sector, the electricity sector may deliver the largest proportional carbon reductions under an economically efficient climate policy. Other frequently discussed means include energy conservation, increasing fuel economy in automobiles, charging plug-in hybrids and electric cars by low-carbon electricity, making individual lifestyle changes, and changing business practices. A range of energy technologies may contribute to climate change mitigation. These include renewable energy sources such as solar power, tidal, ocean energy, geothermal power, and wind power. Nuclear power, the use of carbon sinks, and carbon capture and storage. For example, Pukela and Sokolo of Princeton have proposed a 15-part program to reduce CO2 emissions by 1 billion metric tons per year or 25 billion tons over the 50-year period using today's technologies as a type of global warming game. Another consideration is how future socio-economic development proceeds. Development choices can lead differences in GHG emissions. Political and social attitudes may affect how easy or difficult it is to implement effective policies to reduce emissions. Alternative energy sources, renewable energy. Renewable energy flows involve natural phenomena such as sunlight, wind, tides, plant growth, and geothermal heat, as the International Energy Agency explains. Renewable energy is derived from natural processes that are replenished constantly. In its various forms, it derives directly from the sun, or from heat generated deep within the earth. Included in the definition is electricity and heat generated from solar, wind, ocean, hydropower, biomass, geothermal resources, and biofuels and hydrogen derived from renewable resources. Climate change concerns and the need to reduce carbon emissions are driving increasing growth in the renewable energy industries. Low-carbon renewable energy replaces conventional fossil fuels in three main areas: power generation, hot water/space heating, and transport fuels. In 2011, the share of renewables in electricity generation worldwide grew for the fourth year in a row to 20.2%, with the global share of electricity from hydropower staying roughly constant at 16.3%. Renewable energy use has grown much faster than anyone anticipated. The Intergovernmental Panel on Climate Change has said that there are few fundamental technological limits to integrating a portfolio of renewable energy technologies to meet most of total global energy demand. At the national level, at least 30 nations around the world already have renewable energy contributing more than 20% of energy supply. As of 2012, renewable energy accounts for almost half of new electricity capacity installed and costs are continuing to fall. Public policy and political leadership helps to level the playing field, and drive the wider acceptance of renewable energy technologies. As of 2011, 118 countries have targets for their own renewable energy futures, and have enacted wide-ranging public policies to promote renewables. Leading renewable energy companies include Bright Source Energy, First Solar, Gamesa, GE Energy, Goldwind, Sinovel, Suntech, Trina Solar, Vestas and Yingli. the incentive to use 100% renewable energy has been created by global warming and other ecological as well as economic concerns. Mark Z. Jacobson says producing all new energy with wind power, solar power, and hydropower by 2030 is feasible and existing energy supply arrangements could be replaced by 2050. Barriers to implementing the renewable energy plan are seen to be primarily social and political, not technological or economic. Jacobson says that energy costs with a wind, solar, water system should be similar to today's energy costs. According to a 2011 projection by the International Energy Agency, solar power generators may produce most of the world's electricity within 50 years, dramatically reducing harmful greenhouse gas emissions. Critics of the 100% renewable energy approach include Vaclav Smil and James E. Hansen. Smil and Hansen are concerned about the variable output of solar and wind power, NIMBYism, and a lack of infrastructure. Economic analysts expect market gains for renewable energy following the 2011 Japanese nuclear accidents. In his 2012 State of the Union address, President Barack Obama restated his commitment to renewable energy and mentioned the long-standing Interior Department commitment to permit 10,000 MW of renewable energy projects on public land in 2012. Globally, there are an estimated 3 million direct jobs in renewable energy industries, with about half of them in the biofuels industry. Some countries, with favorable geography, geology and weather well suited to an economical exploitation of renewable energy sources, already get most of their electricity from renewables, including from geothermal energy in Iceland, and hydroelectric power in Brazil, Austria, New Zealand, and Sweden. Renewable power generators are spread across many countries, with wind power providing a significant share of electricity in some regional areas, for example, 14% in the U.S. state of Iowa, 40% in the northern German state of Schleswig-Holstein, and 20% in Denmark. Solar water heating makes an important and growing contribution in many countries, most notably in China, which now has 70% of the global total. Worldwide, total installed solar water heating systems meet a portion of the water heating needs of over 70 million households. The use of biomass for heating continues to grow as well. In Sweden, national use of biomass energy has surpassed that of oil. Direct geothermal heating is also growing rapidly. Renewable biofuels for transportation, such as ethanol fuel and biodiesel, have contributed to a significant decline in oil consumption in the United States since 2006. The 93 billion liters of biofuels produced worldwide in 2009 displaced the equivalent of an estimated 68 billion liters of gasoline, equal to about 5% of world gasoline production. Nuclear power. Since about 2001 the term nuclear renaissance has been used to refer to a possible nuclear power industry revival, driven by rising fossil fuel prices and new concerns about meeting greenhouse gas emission limits. However, in March 2011 the Fukushima nuclear disaster in Japan and associated shutdowns at other nuclear facilities raised questions among some commentators over the future of nuclear power. Platts has reported that the crisis at Japan's Fukushima nuclear plants has prompted leading energy-consuming countries to review the safety of their existing reactors and cast doubt on the speed and scale of planned expansions around the world. The World Nuclear Association has reported that nuclear electricity generation in 2012 was at its lowest level since 1999. Several previous international studies and assessments suggested that as part of the portfolio of other low-carbon energy technologies, nuclear power will continue to play a role in reducing greenhouse gas emissions. Historically, nuclear power usage is estimated to have prevented the atmospheric emission of 64 gigatons of CO2 equivalent as of 2013. Public concerns about nuclear power include the fate of spent nuclear fuel, nuclear safety, and security risks which are considered unique among low-carbon energy sources. A Yale University review published in the Journal of Industrial Ecology analyzing CO2 life cycle assessment emissions from nuclear power determined that the collective LCA literature indicates that life cycle GHG emissions from nuclear power are only a fraction of traditional fossil sources and comparable to renewable technologies. Uncertainties surrounding the future GHG emissions of nuclear power have to do with the potential for a declining uranium ore grade without a corresponding increase in the efficiency of enrichment methods. In a scenario analysis of future global nuclear development, as it could be affected by a decreasing global uranium market of average ore grade, the analysis determined that depending on conditions, median life cycle nuclear power GHG emissions could be between 9 to 110 gCO2 × kilowatt-hour by 2050. During his presidential campaign, Barack Obama stated, "Nuclear power represents more than 70% of our non-carbon generated electricity. It is unlikely that we can meet our aggressive climate goals if we eliminate nuclear power as an option." Nuclear power may be uncompetitive compared with fossil fuel energy sources in countries without a carbon tax program, and in comparison to a fossil fuel plant of the same power output, nuclear power plants take a longer amount of time to construct. Two new, first-of-their-kind, EPR reactors under construction in Finland and France have been delayed and are running over budget. However, learning from experience, two further EPR reactors under construction in China are on, and ahead, of schedule respectively. As of 2013, according to the IAEA and the European Nuclear Society, worldwide there were 68 civil nuclear power reactors under construction in 15 countries. China has 29 of these nuclear power reactors under construction, as of 2013, with plans to build many more, while in the US the licenses of almost half its reactors have been extended to 60 years, and plans to build another dozen are under serious consideration. There are also a considerable number of new reactors being built in South Korea, India, and Russia. At least 100 older and smaller reactors will most probably be closed over the next 10 to 15 years. This is probable only if one does not factor in the ongoing light water reactor sustainability program, created to permit the extension of the lifespan of the USA's 104 nuclear reactors to 60 years. The licenses of almost half of the USA's reactors have been extended to 60 years as of 2008. Two new April 1000 reactors are, as of 2013, being constructed at Vogtle Electric Generating Plant. Public opinion about nuclear power varies widely between countries. A poll by Gallup International assessed public opinion in 47 countries. The poll was conducted following a tsunami and earthquake which caused an accident at the Fukushima nuclear power plant in Japan. 49% stated that they held favorable views about nuclear energy, while 43% held an unfavorable view. Another global survey by Ipsos assessed public opinion in 24 countries. Respondents to this survey showed a clear preference for renewable energy sources over coal and nuclear energy. Ipsos found that solar and wind were viewed by the public as being more environmentally friendly and more viable long-term energy sources relative to nuclear power and natural gas. However, solar and wind were viewed as being less reliable relative to nuclear power and natural gas. In 2012, a poll done in the UK found that 63% of those surveyed support nuclear power, and with opposition to nuclear power at 11%. In Germany, strong anti-nuclear sentiment led to 8 of the 17 operating reactors being permanently shut down following the March 2011 Fukushima nuclear disaster. Nuclear fusion research, in the form of the International Thermonuclear Experimental Reactor, is underway. Fusion-powered electricity generation was initially believed to be readily achievable, as fission power had been. However, the extreme requirements for continuous reactions and plasma containment led to projections being extended by several decades. In 2010, more than 60 years after the first attempts, commercial power production was still believed to be unlikely before 2050. Fuel switching. Most mitigation proposals employ a euro rather than directly state a euro an eventual reduction in global fossil fuel production. Also proposed are direct quotas on global fossil fuel production. Natural gas emits far fewer greenhouse gases than coal when burned at power plants, but evidence has been emerging that this benefit could be completely negated by methane leakage at gas drilling fields and other earlier points in the production life cycle. a study performed by the Environmental Protection Agency and the Gas Research Institute in 1997 sought to discover whether the reduction in carbon dioxide emissions from increased natural gas use would be offset by a possible increased level of methane emissions from sources such as leaks and emissions. The study concluded that the reduction in emissions from increased natural gas use outweighs the detrimental effects of increased methane emissions. More recent peer-reviewed studies have challenged the findings of this study, with researchers from the National Oceanic and Atmospheric Administration reconfirming findings of high rates of methane leakage from natural gas fields. A 2011 study by noted climate research scientist, Tom Wigley, found that while carbon dioxide emissions from fossil fuel combustion may be reduced by using natural gas rather than coal to produce energy, it also found that additional methane from leakage adds to the radiative forcing of the climate system, offsetting the reduction in CO2 forcing that accompanies the transition from coal to gas. The study looked at methane leakage from coal mining. Changes in radiative forcing due to changes in the emissions of sulfur dioxide and carbonaceous aerosols, and differences in the efficiency of electricity production between coal and gas-fired power generation. On balance, these factors more than offset the reduction in warming due to reduced CO2 emissions. When gas replaces coal, there is additional warming out to 2050 with an assumed leakage rate of 0%, and out to 2140 if the leakage rate is as high as 10%. The overall effects on global mean temperature over the 21st century, however, are small. Petron al. and Alvarez al. note that estimated that leakage from gas infrastructure is likely to be underestimated. These studies indicate that the exploitation of natural gas as a cleaner fuel is questionable. Energy efficiency and conservation. Efficient energy use, sometimes simply called energy efficiency, is the goal of efforts to reduce the amount of energy required to provide products and services. For example, insulating a home allows a building to use less heating and cooling energy to achieve and maintain a comfortable temperature. Installing fluorescent lights or natural skylights reduces the amount of energy required to attain the same level of illumination compared to using traditional incandescent light bulbs. Compact fluorescent lights use 2/3 less energy and may last 6 to 10 times longer than incandescent lights. Energy efficiency has proved to be a cost-effective strategy for building economies without necessarily growing energy consumption. For example, the state of California began implementing energy efficiency measures in the mid-1970s, including building code and appliance standards with strict efficiency requirements. During the following years, California's energy consumption has remained approximately flat on a per capita basis while national U.S. consumption doubled. As part of his strategy, California implemented a loading order for new energy resources that puts energy efficiency first, renewable electricity supplies second, and new fossil-fired power plants last. Energy conservation is broader than energy efficiency in that it encompasses using less energy to achieve a lesser energy service, for example through behavioral change, as well as encompassing energy efficiency. Examples of conservation without efficiency improvements would be heating a room less in winter, driving less, or working in a less brightly lit room. As with other definitions, the boundary between efficient energy use and energy conservation can be fuzzy, but both are important in environmental and economic terms. This is especially the case when actions are directed at the saving of fossil fuels. Reducing energy use is seen as a key solution to the problem of reducing greenhouse gas emissions. According to the International Energy Agency, improved energy efficiency in buildings, industrial processes and transportation could reduce the world's energy needs in 2050 by 1/3, and help control global emissions of greenhouse gases. Sinks and negative emissions. A carbon sink is a natural or artificial reservoir that accumulates and stores some carbon-containing chemical compound for an indefinite period, such as a growing forest. A negative carbon dioxide emission, on the other hand, is a permanent removal of carbon dioxide out of the atmosphere, such as directly capturing carbon dioxide in the atmosphere and storing it in geologic formations underground. The Antarctic Climate and Ecosystems Cooperative Research Centre notes that currently 1/3 of humankind unregistered trademark S current present annual emissions of CO2 are absorbed by the oceans. The oceans act as a carbon sink, that is, a reservoir that accumulates and stores carbon via its physicochemical and biological processes. Unfortunately, this vital service comes with the cost of ocean acidification. The ecological effects of ocean acidification are still largely unknown. Research so far has focused on how acidification lowers pH and the level of carbonate ions available for calcifying organisms to form their shells. These organisms include plankton species that contribute to the foundation of the Southern Ocean food web. However, acidification may impact on a broad range of other physiological and ecological processes, such as fish respiration, larval development and changes in the solubility of both nutrients and toxins. According to the CSIRO, the Southern Ocean is absorbing increasing amounts of carbon dioxide, with potentially significant impacts on marine life. Reforestation and avoided deforestation. Almost 20% of total greenhouse gas emissions were from deforestation in 2007. The Stern Review found that, based on the opportunity costs of the land use that would no longer be available for agriculture if deforestation were avoided, emission savings from avoided deforestation could potentially reduce CO2 emissions for under $5 per TCO2, possibly as little as $1 per TCO2. Afforestation and reforestation could save at least another 1 GTCO2/year, at an estimated cost of $5 per TCO2 to $15 per TCO2. The review determined these figures by assessing 8 countries responsible for 70% of global deforestation emissions. Pristine temperate forest has been shown to store 3 times more carbon than IPCC estimates took into account, and 60% more carbon than plantation forest. Preventing these forests from being logged would have significant effects. Further significant savings from other non-energy related emissions could be gained through cuts to agricultural emissions, fugitive emissions, waste emissions, and emissions from various industrial processes. Using evidence from Mozambique, a typical low-income country where agriculture is the dominant provider of income for most citizens, researchers from the Overseas Development Institute found a positive correlation between increased production intensification and reduced land conversion, and crop returns, economic growth and food security. Restoring grasslands stores CO2 from the air into plant material. Grazing livestock, usually not left to wander, would eat the grass and would minimize any grass growth, while grass left alone would eventually grow to cover its own growing buds, preventing them from photosynthesizing and killing the plant. A method proposed to restore grasslands uses fences with many small paddocks and moving herds from one paddock to another after a day or two in order to mimic natural grazers and allowing the grass to grow optimally. It is estimated that increasing the carbon content of the soils in the world unregistered trademark as 3.5 billion hectares of agricultural grassland by 1% would offset nearly 12 years of CO2 emissions. Alan Savory, as part of holistic management, claims that while large herds are often blamed for desertification, prehistoric lands previously supported large or larger herds, and areas where herds were removed in the United States are still desertifying. Carbon capture and storage. Carbon capture and storage is a method to mitigate climate change by capturing carbon dioxide from large point sources such as power plants and subsequently storing it away safely instead of releasing it into the atmosphere. The Intergovernmental Panel on Climate Change says CCS could contribute between 10% and 55% of the cumulative worldwide carbon mitigation effort over the next 90 years. The International Energy Agency says CCS is the most important single new technology for CO2 savings in power generation and industry. Though it requires up to 40% more energy to run a CCS coal power plant than a regular coal plant, CCS could potentially capture about 90% of all the carbon emitted by the plant. Norway, which first began storing CO2, has cut its emissions by almost 1 million tons a year, or about 3% of the country's 1990 levels. As of late 2011, The total CO2 storage capacity of all 14 projects in operation or under construction is over 33 million tons a year. This is broadly equivalent to preventing the emissions from more than 6 million cars from entering the atmosphere each year. Negative carbon dioxide emissions. Creating negative carbon dioxide emissions literally removes carbon from the atmosphere. Examples are direct air capture, biochar, bioenergy with carbon capture and storage, and enhanced weathering technologies. These processes are sometimes considered as variations of sinks or mitigation, and sometimes as geoengineering. In combination with other mitigation measures, sinks in combination with negative carbon emissions are considered crucial for meeting the 350 ppm target, and even the less conservative 450 ppm target. Geoengineering. Geoengineering is seen by some as an alternative to mitigation and adaptation, but by others as an entirely separate response to climate change. In a literature assessment, Barker et al. Described geoengineering as a type of mitigation policy. IPCC concluded that geoengineering options, such as ocean fertilization to remove CO2 from the atmosphere, remained largely unproven. It was judged that reliable cost estimates for geoengineering had not yet been published. Chapter 28 of the National Academy of Sciences report policy implications of greenhouse warming, mitigation, adaptation, and the science base define geoengineering as options that would involve large-scale engineering of our environment in order to combat or counteract the effects of changes in atmospheric chemistry. They evaluated a range of options to try to give preliminary answers to two questions: can these options work and could they be carried out with a reasonable cost? They also sought to encourage discussion of a third question: what adverse side effects might there be? The following types of option were examined: reforestation, increasing ocean absorption of carbon dioxide and screening out some sunlight. NAS also argued engineered countermeasures need to be evaluated but should not be implemented without broad understanding of the direct effects and the potential side effects, the ethical issues, and the risks. In July 2011, a report by the United States Government Accountability Office on Geoengineering found that, climate engineering technologies do not now offer a viable response to global climate change. Carbon dioxide removal. Carbon dioxide removal has been proposed as a method of reducing the amount of radiative forcing. A variety of means of artificially capturing and storing carbon, as well as of enhancing natural sequestration processes, are being explored. The main natural process is photosynthesis by plants and single-celled organisms. Artificial processes vary, and concerns have been expressed about the long-term effects of some of these processes. It is notable that the availability of cheap energy and appropriate sites for geological storage of carbon may make carbon dioxide air capture viable commercially. It is, however, generally expected that carbon dioxide air capture may be uneconomic when compared to carbon capture and storage from major sources, in particular, fossil fuel-powered power stations, refineries, etc. In such cases, costs of energy produced will grow significantly. However, captured CO2 can be used to force more crude oil out of oil fields, as Statoil and Shell have made plans to do. CO2 can also be used in commercial greenhouses, giving an opportunity to kickstart the technology. Some attempts have been made to use algae to capture smokestack emissions, notably the Green Fuel Technologies Corporation, who have now shut down operations. Solar radiation management. The main purpose of solar radiation management seek to reflect sunlight and thus reduce global warming. The ability of stratospheric sulfate aerosols to create a global dimming effect has made them a possible candidate for use in geoengineering projects. Non-CO2 greenhouse gases. CO2 is not the only GHG relevant to mitigation, and governments have acted to regulate the emissions of other GHGs emitted by human activities. The emissions caps agreed to by most developed countries under the Kyoto Protocol regulate the emissions of almost all the anthropogenic GHGs. These gases are CO2, methane, nitrous oxide, the hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. Stabilizing the atmospheric concentrations of the different anthropogenic GHGs requires an understanding of their different physical properties. Stabilization depends both on how quickly GHGs are added to the atmosphere and how fast they are removed. The rate of removal is measured by the atmospheric lifetime of the GHG in question. Here, the lifetime is defined as the time required for a given perturbation of the GHG in the atmosphere to be reduced to 37% of its initial amount. Methane has a relatively short atmospheric lifetime of about 12 years, while N2O's lifetime is about 110 years. For methane, a reduction of about 30% below current emission levels would lead to a stabilization in its atmospheric concentration, while for N2O, an emissions reduction of more than 50% would be required. Methane is a significantly more powerful greenhouse gas than carbon dioxide. Burning one molecule of methane generates one molecule of carbon dioxide, indicating there may be no net benefit in using gas as a fuel source. Reducing the amount of waste methane produced in the first place and moving away from use of gas as a fuel source will have a greater beneficial impact, as might other approaches to productive use of otherwise wasted methane. In terms of prevention, vaccines are in the works in Australia to reduce significant global warming contributions from methane released by livestock via flatulence and eructation. Another physical property of the anthropogenic GHGs relevant to mitigation is the different abilities of the gases to trap heat. Some gases are more effective at trapping heat than others. For example, SF6 is 22,200 times more effective a GHG than CO2 on a per kilogram basis. A measure for this physical property is the global warming potential, and is used in the Kyoto Protocol. Although not designed for this purpose, the Montreal Protocol has probably benefited climate change mitigation efforts. The Montreal Protocol is an international treaty that has successfully reduced emissions of ozone-depleting substances, which are also greenhouse gases. By sector, transport. Modern energy-efficient technologies, such as plug-in hybrid electric vehicles, and development of new technologies, such as hydrogen cars, may reduce the consumption of petroleum and emissions of carbon dioxide. A shift from air transport and truck transport to electric rail transport would reduce emissions significantly. For electric vehicles, the reduction of carbon emissions will improve further if the way the required electricity is generated is low-carbon power in origin. Urban planning. Effective urban planning to reduce sprawl would decrease vehicle miles traveled, lowering emissions from transportation. Increased use of public transport can also reduce greenhouse gas emissions per passenger kilometer. Between 1982 and 1997, the amount of land consumed for urban development in the United States increased by 47% while the nation's population grew by only 17%. Inefficient land use development practices have increased infrastructure costs as well as the amount of energy needed for transportation, community services, and buildings. At the same time, a growing number of citizens and government officials have begun advocating a smarter approach to land use planning. These smart growth practices include compact community development, multiple transportation choices, mixed land uses, and practices to conserve green space. These programs offer environmental, economic, and quality of life benefits. And they also serve to reduce energy usage and greenhouse gas emissions. Approaches such as new urbanism and transit-oriented development seek to reduce distances traveled, especially by private vehicles, encourage public transit and make walking and cycling more attractive options. This is achieved through medium-density, mixed-use planning and the concentration of housing within walking distance of town centers and transport nodes. Smarter growth land use policies have both a direct and indirect effect on energy-consuming behavior. For example, transportation energy usage, the number one user of petroleum fuels, could be significantly reduced through more compact and mixed-use land development patterns, which in turn could be served by a greater variety of non-automotive-based transportation choices. Building design. Emissions from housing are substantial, and government-supported energy efficiency programs can make a difference. For institutions of higher learning in the United States, Greenhouse gas emissions depend primarily on total area of buildings and secondarily on climate. If climate is not taken into account, annual greenhouse gas emissions due to energy consumed on campuses plus purchased electricity can be estimated with the formula, E equals ASB, where it equals 0.001621 metric tons of CO2 equivalent square foot or 0.0241 metric tons of CO2 equivalent square meter, and B equals 1.1354. New buildings can be constructed using passive solar building design, low-energy building, or zero-energy building techniques, using renewable heat sources. Existing buildings can be made more efficient through the use of insulation, high-efficiency appliances, double or triple-glazed gas-filled windows, external window shades, and building orientation and siting. Renewable heat sources such as shallow geothermal and passive solar energy reduce the amount of greenhouse gases emitted. In addition to designing buildings which are more energy efficient to heat, it is possible to design buildings that are more energy efficient to cool by using lighter colored, more reflective materials in the development of urban areas and planting trees. This saves energy because it cools buildings and reduces the urban heat island effect, thus reducing the use of air conditioning. Societal controls. Another method being examined is to make carbon a new currency by introducing tradable personal carbon credits. The idea being it will encourage and motivate individuals to reduce their carbon footprint by the way they live. Each citizen will receive a free annual quota of carbon that they can use to travel, buy food, and go about their business. It has been suggested that by using this concept it could actually solve two problems. Pollution and poverty. Old age pensioners will actually be better off because they fly less often, so they can cash in their quota at the end of the year to pay heating bills, etc. Population. Various organizations promote population control as a means for mitigating global warming. Proposed measures include improving access to family planning and reproductive health care and information, reducing natalistic politics, public education about the consequences of continued population growth, and improving access of women to education and economic opportunities. Population control efforts are impeded by there being somewhat of a taboo in some countries against considering any such efforts. Also, various religions discourage or prohibit some or all forms of birth control. Population size has a different per capita effect on global warming in different countries, since the per capita production of anthropogenic greenhouse gases varies greatly by country. Costs and benefits. Costs. The Stern Review proposes stabilizing the concentration of greenhouse gas emissions in the atmosphere at a maximum of 550 ppm CO2e by 2050. The review estimates that this would mean cutting total greenhouse gas emissions to 3/4 of 2007 levels. The review further estimates that the cost of these cuts would be in the range of 1.0 to plus 3.5% of world GDP, with an average estimate of approximately 1%. Stern has since revised his estimate to 2% of GWP. For comparison, the gross world product at PPP was estimated at $74.5 trillion in 2010, thus 2% is approximately $1.5 trillion. The review emphasizes that these costs are contingent on steady reductions in the cost of low-carbon technologies. Mitigation costs will also vary according to how and when emissions are cut. Early, well-planned action will minimize the costs. One way of estimating the cost of reducing emissions is by considering the likely costs of potential technological and output changes. Policymakers can compare the marginal abatement costs of different methods to assess the cost and amount of possible abatement over time. The marginal abatement costs of the various measures will differ by country, by sector, and over time. Benefits. Yohe al. Assess the literature on sustainability and climate change. With high confidence, they suggested that up to the year 2050, an effort to cap greenhouse gas emissions at 550 ppm would benefit developing countries significantly. This was judged to be especially the case when combined with enhanced adaptation. By 2100, however, it was still judged likely that there would be significant effects of global warming. This was judged to be the case even with aggressive mitigation and significantly enhanced adaptive capacity. Sharing. One of the aspects of mitigation is how to share the costs and benefits of mitigation policies. There is no scientific consensus over how to share these costs and benefits. In terms of the politics of mitigation, the UNFCCC's ultimate objective is to stabilize concentrations of GHG in the atmosphere at a level that would prevent dangerous climate change. There is, however, no widespread agreement on how to define dangerous climate change. GHG emissions are an important correlate of wealth, at least at present. Wealth, as measured by per capita income, varies widely between different countries. Activities of the poor that involve emissions of GHGs are often associated with basic needs, such as heating to stay tolerably warm. In richer countries, emissions tend to be associated with things like cars, central heating, etc. The impacts of cutting emissions could therefore have different impacts on human welfare according wealth. Distributing emissions abatement costs, there have been different proposals on how to allocate responsibility for cutting emissions. Egalitarianism. This system interprets the problem as one where each person has equal rights to a global resource, that is, polluting the atmosphere. Basic needs and Rawlsian criteria. This system would have emissions allocated according to basic needs, as defined according to a minimum level of consumption. Consumption above basic needs would require countries to buy more emission rights. This can be related to Rawlsian philosophy. From this viewpoint, developing countries would need to be at least as well off under an emissions control regime as they would be outside the regime. Proportionality and polluter pays principle. Proportionality reflects the ancient Aristotelian principle that people should receive in proportion to what they put in, and pay in proportion to the damages they cause. This has a potential relationship with the polluter pays principle, which can be interpreted in a number of ways. Historical responsibilities. This asserts that allocation of emission rights should be based on patterns of past emissions. 2/3 of the stock of GHGs in the atmosphere at present is due to the past actions of developed countries. Comparable burdens and ability to pay. With this approach, countries would reduce emissions based on comparable burdens and their ability to take on the costs of reduction. Ways to assess burdens include monetary costs per head of population, as well as other, more complex measures, like the UNDP's Human Development Index. Willingness to pay. With this approach, countries take on emission reductions based on their ability to pay along with how much they benefit from reducing their emissions. Specific proposals, ad hoc, Lashoff and Klein, for example, suggested that allocations based partly on GNP could be a way of sharing the burdens of emission reductions. This is because GNP and economic activity are partially tied to carbon emissions. Equal per capita entitlements. This is the most widely cited method of distributing abatement costs, and is derived from egalitarianism. This approach can be divided into two categories. In the first category, emissions are allocated according to national population. In the second category, emissions are allocated in a way that attempts to account for historical emissions. Status quo. With this approach, historical emissions are ignored, and current emission levels are taken as a status quo right to emit. An analogy for this approach can be made with fisheries, which is a common, limited resource. The analogy would be with the atmosphere, which can be viewed as an inexhaustible natural resource. In international law, one state recognized the long-established use of another state's use of the fisheries resource. It was also recognized by the state that part of the other state's economy was dependent on that resource. Governmental and intergovernmental action. Many countries, both developing and developed, are aiming to use cleaner technologies. Use of these technologies aids mitigation and could result in substantial reductions in CO2 emissions. Policies include targets for emissions reductions, increased use of renewable energy, and increased energy efficiency. It is often argued that the results of climate change are more damaging in poor nations, where infrastructures are weak and few social services exist. The Commitment to Development Index is one attempt to analyze rich country policies taken to reduce their disproportionate use of the global commons. Countries do well if their greenhouse gas emissions are falling, if their gas taxes are high, if they do not subsidize the fishing industry, if they have a low fossil fuel rate per capita, and if they control imports of illegally cut tropical timber. Kyoto Protocol. The main current international agreement on combating climate change is the Kyoto Protocol, which came into force on February 16, 2005. The Kyoto Protocol is an amendment to the United Nations Framework Convention on Climate Change. Countries that have ratified this protocol have committed to reduce their emissions of carbon dioxide and 5 other greenhouse gases, or engage in emissions trading if they maintain or increase emissions of these gases. Temperature targets. Actions to mitigate climate change are sometimes based on the goal of achieving a particular temperature target. One of the targets that has been suggested is to limit the future increase in global mean temperature to below 2°C degrees Celsius, relative to the pre-industrial level. The 2°C degrees Celsius target was adopted in 2010 by parties to the United Nations Framework Convention on Climate Change. Most countries of the world are parties to the UNFCCC. The target had been adopted in 1996 by the European Union Council. Temperatures have increased by 0.8°C degrees Celsius compared to the pre-industrial level, and another 0.5°C degrees Celsius is already committed. The 2°C degrees Celsius rise is typically associated in climate models with a carbon dioxide equivalent concentration of 400 to 500 ppm by volume. The current level of carbon dioxide alone is 393 ppm by volume, and rising at 1 to 3 ppm annually. Hence, to avoid a very likely breach of the 2°C degrees Celsius target, CO2 levels would have to be stabilized very soon. This is generally regarded as unlikely, based on current programs in place to date. The importance of change is illustrated by the fact that world economic energy efficiency is presently improving at only half the rate of world economic growth. Encouraging used changes, emissions tax. An emissions tax on greenhouse gas emissions requires individual emitters to pay a fee, charge or tax for every ton of greenhouse gas released into the atmosphere. Most environmentally related taxes with implications for greenhouse gas emissions in OECD countries are levied on energy products and motor vehicles, rather than on CO2 emissions directly. Emission taxes can be both cost-effective and environmentally effective. Difficulties with emission taxes include their potential unpopularity, and the fact that they cannot guarantee a particular level of emissions reduction. Emissions or energy taxes also often fall disproportionately on lower income classes. In developing countries, institutions may be insufficiently developed for the collection of emissions fees from a wide variety of sources. Making the emitting of CO2 illegal, another option is to replace the emission reduction positive approach proposed with the Kyoto Protocol and its successor with an emitter GHG negative approach. Scientist Ken Caldeira has proposed making greenhouse gas-emitting devices illegal. Subsidies, according to Mark Z. Jacobson, a program of subsidization balanced against expected flood costs could pay for conversion to 100% renewable power by 2030. Jacobson, and his colleague Mark DeLucky, suggest that the cost to generate and transmit power in 2020 will be less than 4 cents per kilowatt-hour for wind, about 4 cents for wave and hydroelectric, from 4 to 7 cents for geothermal, and 8 cents per kWh for solar, fossil, and nuclear power. Carbon emissions trading. With the creation of a market for trading carbon dioxide emissions within the Kyoto Protocol, it is likely that London financial markets will be the center for this potentially highly lucrative business. The New York and Chicago stock markets may have a lower trade volume than expected as long as the U.S. maintains its rejection of the Kyoto. However, emissions trading may delay the phase-out of fossil fuels. The European Union Emission Trading Scheme is the largest multinational, greenhouse gas emissions trading scheme in the world. It commenced operation on January 1, 2005, and all 25 member states of the European Union participate in the scheme, which has created a new market in carbon dioxide allowances estimated at €35 billion per year. The Chicago Climate Exchange was the first emissions market, and is soon to be followed by Asia's first market. A total of 107 million metric tons of carbon dioxide equivalent have been exchanged through projects in 2004, a 38% increase relative to 2003. 23 multinational corporations have come together in the G8 Climate Change Roundtable, a business group formed at the January 2005 World Economic Forum. The group includes Ford, Toyota, British Airways and BP. On June 9, 2005, the group published a statement stating that there was a need to act on climate change and claiming that market-based solutions can help. It called on governments to establish clear, transparent, and consistent price signals through creation of a long-term policy framework that would include all major producers of greenhouse gases. The Regional Greenhouse Gas Initiative is a proposed carbon trading scheme being created by 9 northeastern and mid-Atlantic American states: Connecticut, Delaware, Maine, Massachusetts, New Hampshire, New Jersey, New York, Rhode Island and Vermont. The scheme was due to be developed by April 2005 but has not yet been completed. Implementation puts into effect climate change mitigation strategies and targets. These can be targets set by international bodies or voluntary action by individuals or institutions. This is the most important, expensive and least appealing aspect of environmental governance. Funding. Implementation requires funding sources but is often beset by disputes over who should provide funds and under what conditions. A lack of funding can be a barrier to successful strategies as there are no formal arrangements to finance climate change development and implementation. Funding is often provided by nations, groups of nations and increasingly NGO and private sources. These funds are often channeled through the Global Environmental Facility. This is an environmental funding mechanism in the World Bank which is designed to deal with global environmental issues. The GEF was originally designed to tackle 4 main areas: biological diversity, climate change, international waters and ozone layer depletion, to which land degradation and persistent organic pollutant were added. The GEF funds projects that are agreed to achieve global environmental benefits that are endorsed by governments and screened by one of the GHGs unregistered trademark implementing agencies. Problems. There are numerous issues which result in a current perceived lack of implementation. It has been suggested that the main barriers to implementation are uncertainty, fragmentation, institutional void, short time horizon of policies and politicians and missing motives and willingness to start adapting. The relationships between many climatic processes can cause large levels of uncertainty as they are not fully understood and can be a barrier to implementation. When information on climate change is held between the large numbers of actors involved, it can be highly dispersed, context-specific or difficult to access, causing fragmentation to be a barrier. Institutional void is the lack of commonly accepted rules and norms for policy processes to take place, calling into question the legitimacy and efficacy of policy processes. The short time horizon of policies and politicians often means that climate change policies are not implemented in favor of socially favored societal issues. Statements are often posed to keep the illusion of political action to prevent or postpone decisions being made. Missing motives and willingness to start adapting is a large barrier as it prevents any implementation. Occurrence. Despite a perceived lack of occurrence, evidence of implementation is emerging internationally. Some examples of this are the initiation of NAPA Euro unregistered trademark and of joint implementation. Many developing nations have made national adaptation programs of action which are frameworks to prioritize adaptation needs. The implementation of many of these is supported by GEF agencies. Many developed countries are implementing a Euro first generation Euro unregistered trademark institutional adaptation plans, particularly at the state and local government scale. There has also been a push towards joint implementation between countries by the UNFCCC, as this has been suggested as a cost-effective way for objectives to be achieved. Territorial policies. United States. Efforts to reduce greenhouse gas emissions by the United States include energy policies which encourage efficiency through programs like Energy Star, Commercial Building Integration, and the Industrial Technologies Program. On November 12, 1998, Vice President Al Gore symbolically signed the Kyoto Protocol, but he indicated participation by the developing nations was necessary prior its being submitted for ratification by the United States Senate. In 2007, Transportation Secretary Mary Peters, with White House approval, urged governors and dozens of members of the House of Representatives to block California unregistered trademark S first in the nation limits on greenhouse gases from cars and trucks, according to emails obtained by Congress. The U.S. Climate Change Science Program is a group of about 20 federal agencies and U.S. cabinet departments, all working together to address global warming. The Bush administration pressured American scientists to suppress discussion of global warming, according to the testimony of the Union of Concerned Scientists to the Oversight and Government Reform Committee of the U.S. House of Representatives. High-quality science was struggling to get out, as the Bush administration pressured scientists to tailor their writings on global warming to fit the Bush administration's skepticism, in some cases at the behest of an ex-oil industry lobbyist. Nearly half of all respondents perceived or personally experienced pressure to eliminate the words climate change, global warming or other similar terms from a variety of communications. Similarly, according to the testimony of senior officers of the Government Accountability Project, the White House attempted to bury the report National Assessment of the Potential Consequences of Climate Variability and Change, produced by U.S. scientists pursuant to U.S. law. Some U.S. scientists resigned their jobs rather than give in to White House pressure to underreport global warming. In the absence of substantial federal action, state governments have adopted emissions control laws such as the Regional Greenhouse Gas Initiative in the Northeast and the Global Warming Solutions Act of 2006 in California. Developing countries, in order to reconcile economic development with mitigating carbon emissions, developing countries need particular support, both financial and technical. One of the means of achieving this is the Kyoto Protocol's Clean Development Mechanism. The World Bank's prototype Carbon Fund is a public-private partnership that operates within the CDM. An important point of contention, however, is how overseas development assistance not directly related to climate change mitigation is affected by funds provided to climate change mitigation. One of the outcomes of the UNFCCC Copenhagen Climate Conference was the Copenhagen Accord, in which developed countries promised to provide $30 a million between 2010 and 2012 of new and additional resources. Yet it remains unclear what exactly the definition of additional is, and the European Commission has requested its member states to define what they understand to be additional, and researchers at the Overseas Development Institute have found four main understandings: climate finance classified as aid, but additional to the €0.7 a euro unregistered trademark ODA target. Increase on previous year's official development assistance spent on climate change mitigation. Rising ODA levels that include climate change finance but where it is limited to a specified percentage. And, increase in climate finance not connected to ODA. The main point being that there is a conflict between the OECD states' budget deficit cuts, the need to help developing countries adapt to develop sustainably, and the need to ensure that funding does not come from cutting aid to other important Millennium Development Goals. However, none of these initiatives suggest a quantitative cap on the emissions from developing countries. This is considered as a particularly difficult policy proposal, as the economic growth of developing countries are proportionally reflected in the growth of greenhouse emissions. Critics of mitigation often argue that the developing countries' drive to attain a comparable living standard to the developed countries would doom the attempt at mitigation of global warming. Critics also argue that holding down emissions would shift the human cost of global warming from a general one to one that was borne most heavily by the poorest populations on the planet. In an attempt to provide more opportunities for developing countries to adapt clean technologies, UNEP and WTO urged the international community to reduce trade barriers and to conclude the Doha Trade Round, which includes opening trade in environmental goods and services. Non-governmental approaches. While many of the proposed methods of mitigating global warming require governmental funding, legislation and regulatory action, individuals and businesses can also play a part in the mitigation effort. Choices in personal actions and business operations. Environmental groups encourage individual action against global warming, often aimed at the consumer. Common recommendations include lowering home heating and cooling usage, burning less gasoline, supporting renewable energy sources, buying local products to reduce transportation, turning off unused devices, and various others. A geophysicist at Utrecht University has urged similar institutions to hold the vanguard in voluntary mitigation, suggesting the use of communications technologies such as video conferencing to reduce their dependence on long-haul flights. Air Travel and Shipment. In 2008, climate scientist Kevin Anderson raised concern about the growing effect of rapidly increasing global air transport on the climate in a paper and a presentation, suggesting that reversing this trend is necessary to reduce emissions. Part of the difficulty is that when aviation emissions are made at high altitude, the climate impacts are much greater than otherwise. Others have been raising the related concerns of the increasing hypermobility of individuals, whether traveling for business or pleasure, involving frequent and often long-distance air travel, as well as air shipment of goods. Business opportunities and risks. On May 9, 2005, Jeff Immelt, the chief executive of General Electric, announced plans to reduce GE's global warming-related emissions by 1% by 2012. GE said that given its projected growth, those emissions would have risen by 40% without such action. On June 21, 2005, a group of leading airlines, airports and aerospace manufacturers pledged to work together to reduce the negative environmental impact of aviation, including limiting the impact of air travel on climate change by improving fuel efficiency and reducing carbon dioxide emissions of new aircraft by 50% per seat kilometer by 2020 from 2000 levels. The group aims to develop a common reporting system for carbon dioxide emissions per aircraft by the end of 2005, and pressed for the early inclusion of aviation in the European Union's carbon emission trading scheme. Legal action. In some countries, those affected by climate change may be able to sue major producers. Attempts at litigation have been initiated by entire peoples such as Palay and the Inuit, as well as non-governmental organizations such as the Sierra Club. Although proving that particular weather events are due specifically to global warming may never be possible, methodologies have been developed to show the increased risk of such events caused by global warming. For a legal action for negligence to succeed, plaintiffs must show that, more probably than not, their individual injuries were caused by the risk factor in question, as opposed to any other cause. This has sometimes been translated to a requirement of a relative risk of at least 2. Another route is the World Heritage Convention, if it can be shown that climate change is affecting World Heritage sites like Mount Everest. Legal action has also been taken to try to force the U.S. Environmental Protection Agency to regulate greenhouse gas emissions under the Clean Air Act, and against the Export-Import Bank and OPIC for failing to assess environmental impacts under NEPA. According to a 2004 study commissioned by Friends of the Earth, ExxonMobil and its predecessors caused 4.7 to 5.3% of the world's man-made carbon dioxide emissions between 1882 and 2002. The group suggested that such studies could form the basis for eventual legal action. See also: by country, debate over China's economic responsibilities for climate change mitigation, European Climate Change Programme, mitigation of global warming in Australia, notes. References: Clark, L. A.L., Scenarios of Greenhouse Gas Emissions and Atmospheric Concentrations. Sub-Report 2.1a of Synthesis and Assessment Product 2.1 by the U.S. Climate Change Science Program and the Subcommittee on Global Change Research, Washington, D.C. USA, Department of Energy, Office of Biological and Environmental Researcher, Gallup International, Impact of Japan Earthquake on Views about Nuclear Energy. Findings from a global SNAP poll in 47 countries by Win Gallup International, IAEA, Climate Change and Nuclear Power 2008. A report by the International Atomic Energy Agency, IPCC TAR WG3, Metz, B. Davidson, O. Swart, R. and Pan, J., ed., Climate Change 2001, Mitigation, Contribution of Working Group 3 to the Third Assessment Report of the Intergovernmental Panel on Climate Change, Cambridge University Press, ISBN A0-521-80769-7A. IPCC AR4WG1, Solomon, S. Quin, D. Manning, M. Chen, Z. Markey, M. Averett, K.B. Tigner, M. and Miller, H.L., ed. Climate Change 2007, A Physical Science Basis, Contribution of Working Group I to the Fourth Assessment Report of the Intergovernmental Panel on Climate Change, Cambridge University Press, ISBN A978-0-521-88009-1A. IPCCAR4WG2, Parry, M.L. Kantsiani, O.F. Palitikov, J.P. Van der Linden, P.J. and Hansen, C.E., ed. Climate Change 2007, Impacts, Adaptation and Vulnerability, Contribution of Working Group 2 to the Fourth Assessment Report of the Intergovernmental Panel on Climate Change, Cambridge University Press, ISBN A978-0-521-88010-7A. IPCCAR4WG3, Metz, B. Davidson, O.R. Bosch, P.R. Dave, R. and Mayer, L.A., ed. Climate Change 2007, Mitigation of Climate Change, Contribution of Working Group 3 to the Fourth Assessment Report of the Intergovernmental Panel on Climate Change, Cambridge University Press, ISBN A978-0-521-88011-4A. IPCCAR4SYR, Core Writing Team. Pashori, R.K. and Raisinger, A., ed. Climate Change 2007, Synthesis Report, Contribution of Working Groups I, II and III to the Fourth Assessment Report of the Intergovernmental Panel on Climate Change, Geneva, Switzerland, IPCC, ISBN A92-9169-122-4A. Ipsos, Global Citizen Reaction to the Fukushima Nuclear Plant Disaster. Ipsos Global Advisor. Survey website, Ipsos Mori, polls strong global opposition towards nuclear power, UK Royal Society, Geoengineering the Climate, Science, Governance and Uncertainty, London, UK Royal Society, ISBN A978-0-85403-773-5, RS Policy Document 10/09. Report website. USNRC, Climate Stabilization Targets, Emissions, Concentrations, and Impacts over Decades to Millennia. A report by the U.S. National Research Council, Washington, D.C., USA, National Academies Press, UNEP, The Emissions Gap Report 2012, Nairobi, Kenya, United Nations Environment Programme Executive Summary in other languages. This article incorporates public domain material from the US EPA document, a US EPA, Glossary of Climate Change Terms, Climate Change, US EPA, US Environmental Protection Agency Climate Change Division, External links. Intergovernmental Panel on Climate Change includes the Working Group 3 report Mitigation of Climate Change as part of the Fourth Assessment Report, Why Black Carbon and Ozone Also Matter, in September/October 2009. Foreign Affairs with Veerabhadran Ramanathan and Jessica Seddon-Wallach. The Climate Threat We Can Beat, in May-June 2012. Foreign Affairs with David G. Victor, Charles F. Kennel, Veerabhadran Ramanathan. Google Map of the Rise, Fall, and Migration of Civilization Due to Climate Change, European Union, European Union's European Climate Change Programme, EU New Energy Policy, European Union Greenhouse Gas Emission Trading Scheme, Community Strategy to Reduce CO2 from Light Vehicles. UK's Climate Change Programme, The Stern Review on the Economics of Climate Change. Parts 3 and 4 of the Stern Review are on climate change mitigation. USA, EPA, What You Can Do. U.S. Mayors Climate Protection Agreement signed by 178 mayors representing nearly 40 million Americans, California Climate Change Portal. Academic, Rivington M., Matthews K.B., Buchan K. and Miller D. An Integrated Assessment Approach to Investigate Options for Mitigation and Adaptation to Climate Change at the Farm Scale, NJF Seminar 380, Odense, Denmark, 7 Euro November 8, 2005. Jacobson, M.Z. DeLucky, M.A. A plan to power 100% of the planet with renewables. Scientific American 301, 58 Euro 65 doi, 10.1038/Scientific American 1109-58. PMIDA 19,873,905, Living on a New Earth, Scientific American April 2010, Global Warming Newswire Euro published scientific studies on global warming.